Hello and welcome to video 44. What we're going to do here is we're going to use a really cool program called Audacity. It's free. You can Google it, you can download it, install it. It's a lot of fun, especially when you do things like analyzing tuning forks. I have two tuning forks, both connected to a large wooden box. That makes them a little bit louder. They're supposed to be 256 hertz, but this one has a little piece of metal here that we can move up or down to modify the frequency here, make it somewhat lower. So we're going to analyze that using Audacity. So first I'm going to strike the tuning fork that has not been adjusted, and then I'm going to strike the tuning fork that has the little piece of mass on it that we can slow down the frequency. And then we're going to play both of them together and see what the beats look like. So once you have Audacity open, it's actually really simple. Hit the little red button just like you would on a VCR, or does anybody use VCRs anymore? Let's hit record. So this is the first tuning fork. The second tuning fork, and both tuning forks together. Stop recording. Now we're going to analyze these. What I like to do first, just to get kind of a pretty good estimate, I like to go to Analyze, Plot Spectrum. These are the settings I like to use here. When you put the cursor over there, it tells you just below where my cursor is what the peak frequency is. It says 256 hertz. The second tuning fork should say something somewhat lower. When we analyze the spectrum, it says 251 hertz, which is a difference of 5 hertz, which means we should see about 5 beats per second. Now I'm going to zoom in here, and I like to go to View, Zoom to Selection. And you can see that it looks like it's about 5 beats, but let's quantify it. And the way you can do that is if you just highlight here and you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 beats, like so. It's going to give you a time down here. To turn that into the period, because that's 10 of them, just divide by 10. So that's going to give you a period of 0.1980029 seconds. So let's write that down. So the beat frequency, or the beat period rather, is, looking down here, 0.1980029 seconds. If we want to get the frequency, that's 1 over the period. So when I flip that using my calculator, 1 divided by 0.1980029, that gives me a frequency that's 5.05 hertz, which is consistent with the two frequency measurements we got. Now you may be saying, when we measured that frequency, it only gave us to an integer number. It didn't give us the decimal or fraction of hertz, and I would concur. So we're going to go back and we're going to zoom to normal. And let's analyze those two frequencies the same way we did with the beats and get a little bit more precise number. So highlight a fairly small area, and then go to View, Zoom to Selection. Let's count 10 beats, or 10 waves rather, the same way we did before. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And when we look, here is the period we get. So if we go to here for this first tuning fork, we're getting a period that is 0.0, remember, because we're dividing by 10, 0, 39414 seconds. And when we flip that, we're going to get a frequency that is 1 divided by 0.0039414, and that's going to give us a frequency of 253.7 hertz. And if I go back to Audacity and let me zoom out, actually zoom to normal. We're going to look over here, analyze again, or rather View, Zoom to Selection. Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to write down that frequency, or that period rather, 0.00400 and when we turn that into a frequency by flipping it, 1 divided by 0.004066, we get 249.6, and when we subtract those two, 253.7 minus 249.6, that gives us a difference in frequency of 4.1 hertz, which isn't as close to 5 as I would like, but I think you get the idea, the kind of analysis you can do here. And if we wanted to, we could actually play this back. This is the first tuning fork. The second tuning fork. And both tuning forks together. So those are beats. I hope that you found this useful. I do want to mention, if anybody's trying to do this at home, there's always a little bit of a danger with the onboard microphones on laptops. They tend to skimp there, so I'm actually using an external microphone if you're trying to do this yourself. Hopefully somebody out there found this useful, and Audacity really is an amazing program for something that is free.